All right, so for this video, we're talking about finding density using the water displacement method. Now remember, the water displacement method is what you guys did in the lab, where you looked at the initial reading in a graduated cylinder, and you looked at how it changed once you actually added a solid. And so let's just say we added our solid in here. Now, the difference between where that water level started and where it ended represents the volume of our solid. And so as we're looking at this one, if we kind of picture a line being drawn across with where it's starting and where it's ending here, this difference represents the volume of our solid. And so with that in mind, we can then actually solve this problem, but with the first step of being able to find the volume of our solid. So our question says you're in the lab and you record the initial measurement of water to be 5.30 milliliters. Then you place an unknown solid that has a mass of 14.42 grams into the water. The new water level is now 8.74 milliliters. What is the density of the solid? So for this one, to start off, we need to find the volume of our solid. And so to do that, we need to take our final measurement, 8.74 milliliters, and subtract it from our initial measurement, 5.30. And so when we do this, this is going to give us 3.44 milliliters. And remember, this represents the volume of our solid. And now that we have the volume of our solid, we can go back and solve for the density of our solid using our density equation, D equals M over V. Or in this case, the 14.42 grams given from our question divided by the 3.44 milliliters that we just solved for. Now, when we do this and we plug it into our calculator, we end up getting 4.191860465 grams per milliliter. Now, remember, we don't want to record that many numbers as a final answer. And so we need to use our sig fig rules in order to determine what answer is actually correct. So in this case, since we're multiplying and dividing, it goes by, remember, the fewest number of sig figs. And in this case, in our calculation, the 3.44 only has 3 sig figs, which means our final answer should also only have 3, which means that in this case, we're drawing our invisible cutoff line right after the 9. Now we look at the first digit after the 9. In this case, it happens to be a 1. So that's going to round down, which means our final answer should be 4.19 grams per milliliter. Or in this case, our third answer choice.